Welcome to the live stream for the Starliner launch, which is going to be flying in just about 20 minutes. What is interesting about this is that this will be the second test for the Starliner vehicle, and it's all part of the commercial resupply or commercial crew program, which was started way back in the 2000s. And now this is finally the culmination of the testing campaign, we hope, for the Starliner vehicle. If you know also the Dragon 2 vehicle, that's also part of this commercial crew program that was started back in 2000s. And the purpose of this program was basically to replace the space shuttle. So it's been 11 years now, I think, since the space shuttle was retired. So this is one of the vehicles that's supposed to be replacing that. The other one being the Dragon spacecraft, built by SpaceX. So if all goes well today, then we'll officially have 2 spacecraft built by America, which can go to the International Space Station, which will be pretty exciting. Good to have some diversity and not just have one rocket and one spacecraft dominating the market. Kind of how SpaceX and the Falcon 9 have been doing lately. So there are lots of interesting things about the vehicle that's going to be taking Starliner to the International Space Station, that vehicle being the Atlas V. And we're going to talk a little bit about that today. And we're also going to tune in, of course, to the live launch to watch it all happen. And we're also going to talk a bit about Starliner itself too, and why it's special, what makes it unique, and some of the interesting design features that it has that help it do its job, and also maybe are some advantages that it has over other vehicles, and maybe also some challenges that it has over other vehicles as well. So without further ado, let's get into it. First, let's just go to the main NASA stream. It looks like they're looking at the weather here. Of course, weather is always a driving factor for whether a rocket can launch. So as far as we know at this point, the weather is looking good. So we are clear to launch at this point. Of course, that can always change. So we'll always have to keep in mind to be watching the weather. The launch today is an instantaneous launch window. So what this means is basically if everything is not good on exactly the time, then you have to wait until like tomorrow or something. But here we see that we're at a 90% chance that we'll have good weather, and we are still a go as of right now. So this is all good news. But we'll keep this in mind for the coming minutes as to whether we'll be good for weather. So let's talk a little bit about the vehicle that's going to take Starliner to the International Space Station, the Atlas V. So the Atlas V is going to be flying in an interesting configuration. It's basically this vehicle that you see on the screen. Obviously, there are many different types of rockets that are here. What makes them all different, it's all the Atlas V, but what makes them different is basically how many of those white solid rocket boosters that are on the sides, and also the type of fairing that the rocket has. That's the kind of the pointy part at the top. And also the number of engines that are in the second stage, which is basically the white stage that is on top of the orange piece of the rocket. And in this case, we're going to be flying on the N22 type. And what this means is that there are 2 solid rocket boosters and 2 engines in the second stage that are on top of that orange part, and that we don't have a fairing. And of course, we don't have a fairing because the Starliner is going to be on top. So it kind of is acting like its own fairing. It's kind of shaped like a cone, so you don't really need a fairing to cover it. All the other types are kind of used for moving payloads up into orbit. So this is interesting because it is the only configuration for moving human-rated vehicles into orbit. So yeah, the N22 configuration is what we're using today. And each of these codes is, again, referring to the different parts of the Atlas V rocket. So for all the ones that start with 400, that means that they have a 4-meter payload fairing. And for all the ones that start with 500, that means they have a 5-meter payload fairing. That has to do with the width of the payload fairing we're talking about. The number in the middle is indicating how many of those solid rocket boosters that they're using. So you can see in the pictures on the bottom how that number in the middle is changing how many boosters we have. And then finally, the last number is indicating how many of the engines we have on the second stage. So if you ever want to know what the Atlas V variant codes mean and what they're talking about when they're flying like a 501 or a 421 or something, you can always refer to this chart and kind of figure out what's going on. So let's talk a bit about the rocket. The main stage, which is this orange part, is powered by the RD-180 engines. And these engines are actually Russian built. So there has been some controversy in the last couple of years about whether ULA should be using these Russian engines for obvious political reasons. So in the future, they're planning to discontinue this, but I think we should definitely appreciate the marvelous engineering of the RD-180 engines. They're absolutely fantastic. They run on kerosene and liquid oxygen, and they're able to produce quite a lot of thrust. You just need, and also let's mix a little bit of the fuel and the oxidizer before they send it into the engine, and they use that in order to power the pumps that pump all of that stuff into the combustion chamber and into the engines. So yeah, in this engine we have basically one pre-burner and pump piece, but we have two combustion chambers and nozzles. So it's kind of like 2 for 1, I guess. I don't know. It's definitely a unique engine configuration, and you could get lost in the engine details, but I won't bore you with those details. Yeah, if you want to know what the stage combustion cycle kind of looks like in a diagram, this is kind of what's going on the inside, except instead of just having the one combustion chamber and nozzle you see here, you would have two. So, but basically, yeah, you see some of the fuel and oxidizer go to this pre-burner, and then that is what powers the pumps that push all the fuel around, and then everything in the end goes into the combustion chamber. So the other engines that are on this vehicle are, of course, the ones that are on the second stage, and these are interesting because they are actually using what's called the expander cycle. And the engine that's on here is called the RL10, and it is absolutely a fantastic engine and a marvel of engineering. And I believe it's also the most efficient engine that has ever been built and flown. I'm sure they've built more efficient ones that never flew, but what does this mean? Basically, it gets the most velocity and push for the same amount of fuel. And it does this by utilizing liquid oxygen and hydrogen and having a really big bell to expand those gases to really extract as much speed out of them as possible. And the reason why hydrogen is so good is because it is a light gas. So light gases are able to accelerate through a combustion reaction much better. And the combination of liquid oxygen and hydrogen is the one that gives you the most energy. So ultimately, it's kind of like destined to be the most efficient. And the beautiful thing is that the exhaust products are just water. So it's like also the cleanest engine that is out there. So that's also fantastic. Here's a diagram of the expander cycle engine if you're interested. And you can see here that what's happening is basically the fuel is being run through the nozzle before it goes into the combustion chamber. And what that's doing is it's extracting heat out of the walls of the combustion chamber, so it's actually cooling the combustion chamber. There's like no metal that can withstand those temperatures. So you're getting the function of cooling down the combustion chamber walls by doing this. But at the same time, the energy that's extracted by the hydrogen when it heats up because of the combustion chamber walls allows that fuel that now is gaseous to flow through a turbine, which will then run the pumps. So instead of having a pre-combustion chamber like some of the other rockets, you can kind of skip that step and just use the fuel's own expansion that from heat on the combustion chamber to drive the pumps. So it's actually a really simple rocket in this respect. Yeah, really cool engineering there. Let's go back to the main channel. So yeah, we're about 13 minutes away from launch. Yeah, they're still going on with the talks with some of the important people, I guess, in NASA that are discussing this. Let's talk a little bit about the mission profile that Atlas will take. So basically, we start in step 1, which will be the ignition of both the solid rocket boosters and the main engine. So, and then the rocket will ascend and go through the atmosphere. It'll go through what's called max Q, which is when we have the most aerodynamic pressure. I think that'll happen about 1 minute into the flight. And then at about 2.5 minutes, the solid rocket boosters will run out, and they'll basically be separated and jettisoned from the vehicle. And then it'll just be the core stage that keeps going. And then we move into step 3, where we're going to have the shutdown of the main engine. And then the second stage, which is the white part on the top, is going to separate from the main stage. And then we move to step 4, where that second stage is going to ignite and continue pushing the Starliner all the way into orbit. Once the Starliner reaches orbit, the second stage is going to jettison the Starliner vehicle, and it's going to fly off on its own. And it'll be its own vehicle, and it'll try and eventually navigate itself towards the International Space Station, where basically it's going to come and it's going to dock. That won't happen today, but it'll usually takes about a day for the Starliner to eventually get to the International Space Station. And they're going to do lots of like tests along the way, so they'll probably hold the Starliner vehicle for a little while. So it might be a couple of days before they actually do the docking. And the reason for this is that this is, of course, a test vehicle, and if you have a vehicle with propulsion systems on it, like Starliner does, if something is going wrong, of course, you don't want to have a chaotic vehicle that might, crash anywhere near the station. So usually they do a whole bunch of checks to make sure that it's all good. All right. A little bit about the Starliner vehicle itself, because it's actually quite an interesting vehicle. It has a lot of parts. Here we can kind of see the breakdown of some of the main components. Of course, the part labeled A is the main part of the vehicle where all the people and astronauts will be living in. It has a volume of about 11 meters squared, which may be hard to conceptualize, but basically, if you imagine a room that's about 2 meters by 2 meters by 2 meters, which would be a really small room, actually. You probably wouldn't want to live in that kind of a room for very long. It would be just a little bit bigger than that. But you have to remember that this vehicle's in space, so it's kind of more spacious when you can kind of utilize like the ceiling and the walls and stuff. So it's not so bad. They can actually fit 5 seats in there. So number 6 here on the diagram is the heat shield, and that's going to help the vehicle come back, of course, from Earth. Back to Earth. The part that's labeled B here is basically the module that holds all of the propellant that they're going to use to navigate and reorient and then finally deorbit the spacecraft. It also has the ability to perform an emergency escape. So these rockets here on the bottom have actually quite a lot of thrust. I think they have like 20 kilonewtons each. So in the end, the capsule's able to make like 8 Gs of acceleration, so they can really get away from the vehicle really quickly with these rockets. They also have solar panels on the back, so the vehicle will kind of orient itself like with its butt to the sun, so that the solar panels will be able to charge. And then finally, on the top here, you have the nose cone and the adapter that's going to dock onto the International Space Station. All of these parts are going to be tested a lot in the next couple of days to make sure that they're all functioning properly. All right. Let's head back to the main channel. One thing that's interesting here is that Starliner is actually doing this test for the second time. And if you'll remember back to the Dragon spacecraft days, it only did one test before it went to the International Space Station with people on it. So why does Starliner have to do another test? Well, 2.5 years ago, in December of 2019, I think is when they did their first test. They had a whole bunch of issues that they were when they started doing the testing. First of all, when Atlas V put the Starliner into orbit, the Starliner was not able to hold its orbit because the maneuvers that Starliner was making were not properly timed. So basically, when you're in orbit and you don't make a maneuver at exactly the right time, when you're pointing in the same direction, it can kind of have a very different effect on how your orbit behaves. So when you think you're trying to push your orbit up, if you are not timing it properly, you could actually be pushing your orbit down. And that's kind of what was happening with Starliner. So they actually ended up burning so much fuel trying to compensate for these timing issues that they actually weren't even able to make it to the station anymore. So they had to kind of cancel that part of the mission. So they couldn't test those things with the docking. And then they also had a whole bunch of other bugs in their software that were causing other issues. And they even fixed one of the bugs on the fly because the trunk of the spacecraft is supposed to separate before it comes back into the atmosphere, of course, because the heat shield is in between those two. If we go back to the diagram, you can kind of see that. And one of the problems was that the trunk was actually going to separate in a way that as it came back in the atmosphere, there was a chance that the Starliner could actually crash back into the trunk. So that would have been really bad. In the end, they solved that error before they ended up coming back into the atmosphere. So, but all these errors were not good for its first mission, and they had to kind of go back to the drawing board and make sure they wouldn't see these problems again. And then they were planning to launch this back in 2021, but in the end, they were having some difficulties with some of the valves that were in the Starliner's propulsion systems. Basically, Starliner uses hypergolic propellants, which means that they ignite on contact when you mix them together, which is good for simplicity. But the problem is that these chemicals that do this are usually quite toxic, and some of the hydrazine which they were using had leaked past one of the valves and had mixed with some of the moisture that was in the air in Florida, and basically caused this valve to corrode and freeze up. So again, they had to roll it back and reconfigure the vehicle and change out the valves, and I think they had to change the entire trunk module. So yeah, a bit frustrating. But finally, we're back on the pad again. It looks like all these errors are finally resolved. So we're looking forward to see this vehicle in action and see some of the test data they're going to have coming into the space station. So let's turn on the audio here.
Houston flight is go. Launch director. You have
yeah, Taha, you said that stream is stuttering. I hope it's not stuttering too badly. Maybe I'm having some bad internet. If that's the case, I 100% apologize.
Times. We've pulled for launches to the sun, the moon, Mars,
but hopefully
Jupiter, Pluto,
it's good enough that you can tell what's going on
mission
in
and every
the
countdown is unique and exciting, but
launch.
the ULA team is absolutely thrilled to put Mighty Atlas back in service of human spaceflight.
If you guys continue to have problems with that, just let me know.
Have told me that they feel so confident about eventually riding on top of an Atlas V rocket because it's been all over the solar system. It's pretty amazing.
It's an amazing machine.
We should be hearing Starliner configured for terminal count here in just a few seconds.
L-5 minutes. LC flight. Starliner configured for terminal count. Roger.
There you go. Starliner is now configured for terminal count.
L-4 minutes and 45 seconds. All steps are complete prior to terminal count.
And Lauren, with that call, that all of the work is now complete, and the computers are going to take over the automated countdown at T-minus 4 minutes, coming up in here in just about 30 seconds.
L-4 minutes and 30 seconds.
Just a beautiful shot there.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. 3:55. Ground pyros enabled.
Ground system ordnance has been enabled.
.330. Atlas hydraulic to flight pressure.
Atlas's hydraulic steering system has been pressurized for flight.
Okay, so we're coming up into the final 3 minutes of the countdown. Everything is looking good so far. We haven't had any bad news yet. You can see some of the vapor clouds coming off the vehicle. That is just the liquid oxygen that is boiling off in the main stage.
3 minutes to launch.
This is because those
Securing
propellants are
LO2
stored
top.
cryogenically. So
Pressurizing Atlas tanks.
when
Topping
when
of
they're in the
liquid
tank, they start to
Atlas has
warm
now
up.
Completed, and Atlas propellant tanks are
FPS
pressurized for
internal.
flight.
Yeah, when the oxidizer starts to heat up, obviously you have to kind of let some of it go, otherwise you have overpressurization. But it looks like the propellant loading is complete, so this is a good sign.
Two minutes.
159,
Vehicle internal.
155,
Bot sequencer start.
150,
Securing Centaur LH2.
Securing Centaur LO2.
Centaur hydrogen and oxygen are now at flight level, and topping is being terminated.
140,
Okay,
Launch
the
enabled.
137,
fueling has just finished.
FPS arm. $120,
OCU's armed.
SES count started. EDS ascent.
EDS armed and ready means the emergency detection system is now armed.
1
And that
minute,
basically just means
Rob,
that
report
if it
range
detects
status.
something, it will
Range
trigger the
green.
launch abort system on Starliner and fire
54.
automatically. The
PLP
spacecraft
started.
would push itself far up and away from the rocket. We're talking a mile up and a mile out in just a matter of seconds. We certainly don't expect to see that today.
All right, coming up close here to the launch. Everything is going good so far. We don't have any things that could come up. The vehicle's in a terminal count now, so that means that the automation
30
on the
seconds.
system.
Centaur at flight press.
Vehicles now pressurized for flight.
25,
Status check.
Go Atlas,
Go Centaur.
Go Starliner.
All systems are go for liftoff.
Go Starliner. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff. Starliner is headed back
Here
to
we
space
go.
on the shoulders of Atlas, powered by a workforce dedicated to its success.
It's great to see this.
We have confirmation of a good MET epic timer on Starliner.
Atlas
There we
executed
go.
its roll program.
Already ready is now
Gives you
throttling
strategy
down to
with the
maintain
crew and a
acceptable
heads-up
dynamic
position
pressure
if
on
we
the
had crew
vehicle.
on board today.
This is the first planned throttle down for Atlas in preparation for max Q.
Max Q, maximum dynamic pressure on the vehicle.
All right, so the next thing that's going to be coming up.
Atmosphere reports these are the highest Starliner Atlas will face during the uphill climb.
That's a nice tracking shot. There you can actually see an interesting part of the vehicle, which is that the solid
Block
rocket
1,
boosters.
Atlas 5 and Starliner are now supersonic. Vehicle now throttling up.
Up next in about
Engine
20
response
seconds,
is looking good.
Starliner's 2 solid rocket boosters will run out of fuel and burn out.
The vehicle needs those solid rocket boosters because the main stage doesn't have enough thrust to actually get itself off the pad on its own.
And we have burnout on both SRBs.
Good crew module forward link connection.
Already ready is throttling back up to full thrust.
Now that we pass the solid rocket booster burnout, you'll soon see those 2 solid rocket boosters separate from the vehicle.
We should have separation pretty soon here. This tracking shot's really quite impressive, I would say. They
Atlas
got a nice
5 now
camera on
weighs
it.
just one half of what it did at launch, burning propellant at a rate of 2,800 pounds per second. And we have indication of SRB jettison.
Nice.
Atlas continues to ascend using solely the RD-180 engine. That's about
2 minutes remaining in the booster
850,000
phase of
pounds of
flight.
thrust at sea level.
So the RD-180s are going to burn for another minute or two here, and then we're going to have the booster separate from the main state, the upper stage of the vehicle.
We're now 2 minutes and 55 seconds into today's flight, flying at an altitude of 56 kilometers.
And you can really see how wide that exhaust plume goes. Like the gray stuff that you're seeing coming off the rocket, that's actually the exhaust, the near vacuum at this point. And that gives the vehicle a little bit of extra thrust.
1 minute to BECO. RD-180 is now throttling to maintain 3.5 G acceleration on the vehicle.
Starliner flying off the east coast at this point at altitude of 80 kilometers now, moving at a rate of 1,187 miles per hour.
It's just passing North Carolina and Virginia off the northeastern seaboard. For those of you watching along the coastline, you might be able to see this launch.
So we should have the main booster separation coming up real soon here. Looks like they're switching us to the animation.
We have BECO, booster engine cutoff.
What is this? We want to see the separation.
We have successful staging. Pre-start on the RL-10s.
This is the one negative of the ULA streams, is that they always switch to the animation eventually.
We have ignition on both RL-10s.
The reason why they do that is because the vehicle the vehicle goes so far downrange on the first stage that basically they go out of the range of the ground station that they're connected to. And there you just saw the skirt that was covering the Centaur body get jettisoned. And the reason why they do that is because it's out of the main atmosphere. And the skirt is specifically designed to protect the Centaur upper stage from the loads that come from the shocks of the Mach. When you go past the speed of sound, there's kind of like a shock wave that builds up. And they did some calculations and found that that could actually be a problem if they didn't have that skirt there. But once you're out of the atmosphere, then it doesn't matter anymore because there's no air. So and this is also the only Centaur upper stage that has 2 of the engines on it. And that's because they needed to have extra thrust to get
Now 6 minutes into today's
the vehicle into orbit a little bit faster. And this had to do with the safety of the vehicle and the people inside of it. It's better to get into orbit quicker in the case that you have like a problem, because then you're kind of moving faster and you can have a shallower re-entry in the case of a problem. If you kind of go slowly, like the Atlas V is kind of designed to get things into orbit, you basically run into problems with having too steep of a descent if there's a problem, and then you have heating issues, and then there's risks to whether the vehicle will actually survive or not. So that's kind of the reason why we have 2 engines instead of just 1.
We heard a report from ULA's team. We had a little bit of an overperformance on the booster, but that's a good
5
thing.
minutes
Centaur
remaining.
is more than
Centaur.
capable of adjusting on the fly in its closed-loop performance.
Another thing that's interesting about the upper stage here is that it's kind of a lot weaker when you compare it to some of the other upper stages that are out there. So, like for instance, the Falcon 9. So it'll burn for a lot longer than the Falcon 9 will. And the reason for that is that they're using, of course, the RL-10 engines, which are expander cycle engines. And these have limits to how much thrust you can create because they are creating the pressure and the force to put the propellants into the combustion chamber through heat from the combustion chamber. And that runs into physics limitations at around 50 to 100 kilonewtons. So basically, they're kind of limited by this. Even though they're really efficient, they're not super powerful. So they kind of have a longer, they take a little bit longer to get all the way to orbit.
We heard confirmation that St. John's abort zone is open. We pre-select these splashdown zones in the case of any needed aborts. The first one would be off the coast of St. John's, Nova Scotia. We just heard the flight dynamics officer report everything is pretty good.
I'm not sure how accurate
Mission control confirming that our main engine cutoff time is looking stable. It is going to be 11 minutes and 50 seconds into the flight. We are now 8 minutes and 50 seconds in, so that's still about 3 minutes to go until we hit that milestone.
So it looks like we're just passing Massachusetts there. You can tell by what we're passing on the map in the animation. It's really incredible how far it travels over the course of just the 9 minutes that it's been going. Like it's basically gone across the entire country of America. One thing that I do miss is the altitude indicator for how high the vehicle's going and how fast it's going. It would be nice if ULA would add that to the stream. It's just the engineer in me likes to see some numbers other than just the time.
We pre-plan our flight trajectories so we would not abort a crew into the middle of the ocean. They'd be near enough to land for quick and speedy recovery. So we're still in that St. John's abort zone. Expect to hear that Shannon open call coming.
And we just heard that call. Shannon now open, so Starliner could potentially make that abort landing off the coast of Ireland now if needed, but so far no reason to think it will be. Starliner currently 153 kilometers above the Pacific Ocean, the Atlantic Ocean, and that's about 95 miles.
So you can see how they kind of have different abort zones as they go through the flight. Basically, if there ever is a problem, they can use these and have the Starliner, of course, separate and get away from the vehicle that is, I guess, failing. And I think they also have like rescue crews that are standing by in these areas that could quickly respond in that case.
Centaur and Starliner are passing Mach 23, Mach 23.3 and counting.
So we should almost be in orbit now at Mach 23. I think we have to get up to about
of just under 150 kilometers.
MECO's main engine cutoff when both of the dual engine Centaur RL-10s are scheduled to shut down. That again is coming up at 11 minutes and 50 seconds. About 5 seconds away now.
And we have MECO 1. Centaur engines have cut off. RCS is now at 100%
Main engine cut off,
for us.
right on time. Starliner is in space, but not done with the ascent milestones. Hearing in the room that it was a good main engine cutoff. The next milestone that we'll be looking for is launch vehicle separation, when Starliner will separate from Centaur booster and fly on its own.
So we've
Even after that happens, we'll have about 15 minutes until our final major milestone in today's ascent, the orbital insertion burn that will raise the perigee, or low point of Starliner's orbit, out of the Earth's atmosphere. So stick with us, we're not done yet. Now 12 minutes and 30 seconds into today's flight.
So the vehicle has just gotten itself into orbit. One thing that's interesting is you may have noticed that the orientation of the vehicle as it was doing its burn
We just heard our
was kind of in a inclined way to the plane of the Earth, and the reason for that is again because of the low thrust of the stage of the rocket engine. So basically, it has to kind of keep itself pitched up so that the apogee of the orbit keeps staying in front of itself. I don't know. This is tough to explain. If you've played Kerbal Space Program, you'll know what I'm talking about. This is what happens when you have a weak engine. In the end, you kind of have to, if you're designing a rocket, you have to balance the fact that you have less thrust with the efficiency, because, of course, higher efficiency means that you are getting more thrust for less propellant. So balancing those two can be is basically how you design the best rocket, and Atlas V has a really good way of doing that.
Centaur has now achieved its separation attitude.
Just under a minute now to go until the launch vehicle separation. The team here on the ground reporting that Starliner and Centaur are both ready for it, in the right orientation and on a stable trajectory.
All right, the next step should be the separation of the
30 seconds to
Starliner.
Starliner separation.
30 seconds away. Okay. Basically, the vehicle and the trunk are going to separate from the frame wire frame looking
is
thing.
holding attitude for Starliner separation. 10 seconds to separation.
And we have confirmation of Starliner separation.
There she goes.
And Starliner is flying alone on its way to orbit. Confirm.
I feel like it's worth it, though, to put some cameras on those parts and get a ground link, because it would be really cool to see those separations live. Yeah, I don't know. They spend billions of dollars on this rocket. They could just put a camera there.
Raise the perigee, or the low point of Starliner's orbit, out of the Earth's atmosphere, putting it in space for its full orbit. That's an important milestone to reach. It's going to be a 45-second burn. It'll change Starliner's velocity about 85 meters per second, or 190 miles per hour. And that's going to be coming up at the 31-minute mark in today's orbit. We're now just under 16 minutes into today's flight, so still about 15 minutes to go for that.
So there's a number of things that flight controllers are working on right now. They're transitioning Starliner from its launch mode over to its orbit mode. That includes powering up things like antennas, heaters, and those radiators that I mentioned earlier. We have good targeting for orbital insertion, a good forward command link, and a good MET epoch timer. Starliner making its way over the North Atlantic. Some other things going on right now. They are powering down some what's called demonstration flight instrumentation. We have some extra sensors on there for these demonstration flights. We have more of them on during power descent, but we don't need some of those right now, so flight controllers are powering some of those down. But some other things that are powering on include those propulsion line heaters. When in the vacuum of space and in the Earth's shadow, it gets quite cold, around negative 250 degrees, so we want to make sure those propulsion lines don't freeze. And And the radiators are those little small silver discs you might be able to see on the side of the service module. If you remember your high school physics, the only way you can get rid of heat in a vacuum is through radiation. And so that sublimator will be powering down, and the radiators will be taking care of the heat management for the rest of the flight until we get ready to come home. Some things that you also might be seeing on your screen are some RCS jet activations. Those are just helping to target for that orbital insertion burn.
So basically, Atlas V gets the vehicle almost into the right orbit, and then Starliner is responsible to get itself the rest of the way. So this is where we had the problem last time. Basically, Starliner wasn't able to do this step properly. So hopefully, all will be clear this time.
That orbital insertion burn, as Brandy mentioned earlier, we want that 85 meters per second of delta V to be going in exactly the right direction. And so the colors you're seeing on your screen,
Right. The colors you're seeing on the screen are indicating Starliner's track right now. Starliner is currently coming up on the coast of Europe and is about 224 miles, 139 miles, 224 kilometers above the Atlantic Ocean as it makes its way to the topmost or highest part of this orbit. It will be heading southeast over Europe and a little bit of Africa in the next few minutes as it begins its journey to start catching up with the International Space Station. Again, one of the major milestones coming up in preparation for that is the orbital insertion burn, coming up at the 31-minute mark into today's flight. We're now just over 19 minutes in.
All right, so basically Starliner's going all the way to apogee, and then once it gets to that apogee, it's going to do this orbital insertion burn. And we should be only a couple minutes away from that. Of course, we always do the circularization at apogee because that is the lowest energy point where you would do that maneuver.
confirmation we still have a good forward link command connection.
The problem that happened last time was that they weren't able to properly time this burn, and so because you're going so quickly in your trajectory, if you miss apogee, then basically your burn doesn't quite work as well, and then you might run out of fuel and not have enough to get to your destination.
Getting a look at the number of teams who have been supporting today's launch all across the U.S., in particular here in Houston. If you hear of the flight director Mike Lammers and Rick Hempling, who's been assisting him, particularly with weather observations. And earlier you saw several of the teams who have been supporting from the launch site in Florida. Now 21 minutes into today's flight. That's just about 10 minutes away from that orbital insertion burn that we're watching for. It's coming up at 31 minutes into the flight.
So yeah, we have a little bit of time until that final orbital insertion is completed. So maybe we can talk a little bit about some of the interesting aspects of the Starliner vehicle. One thing that's interesting is it has like how does it stack up against the Dragon 2 essentially? So what are the differences between the vehicles and what are the main selling points? So the first obvious thing that is different between them is the space that's available inside of them. So Starliner comes with about 11 meters cubed of space that it can use, whereas Dragon only has about 9.5 meters cubed or so. So Starliner is a bit more spacious. with that extra space, Starliner is able to utilize that and put in actually a fifth seat. So Dragon 2 only has 4 seats, but the Starliner has 5 seats. So theoretically, they can actually sell more seats than Dragon 2 can. So they're kind of getting more bang for their buck in that case. But how much do these seats cost? Well, the Starliner vehicle's seats cost $90 million per seat, which means that NASA is paying, if they put all the astronauts on there, 360. Wait, let me do the math in my head here. They pay $450 million for an entire full vehicle. NASA usually is only planning to put 4 astronauts on the Starliner though, so usually they'll just sell it for $360 million. But they do have the option that they could sell that 5th seat to maybe someone in the public or someone who wants to go to the International Space Station. Now space tourism is a thing, right? So someone might buy that seat. Compared to the Dragon though, Dragon only costs about $55 million. So in terms of cost effectiveness, it looks like Dragon 2 is maybe winning this part of the competition. What's interesting though is that Starliner is not actually cheaper than NASA was paying to the Russians to go to the International Space Station. So Soyuz was only costing about $80 million per seat. So there are some questions about whether the Starliner is really like an effective solution to getting to orbit, if it's really costing more money. But yeah, anyways, that's just politics. Obviously, it's better not to have to rely on the Russians. So,
Based on what was going through your mind at that moment?
Yeah, it's pretty amazing. Actually, leading up to this, I've been thinking about all the teams all over the country who are supporting this. You know, of course, here in Florida, but then back in Houston and Denver. It's just a huge team to get this thing off the ground and to get Starliner into flight. So at the moment of liftoff, I have to admit, though, I was thinking about what it's like to be sitting inside of there. So, you know, unabashed to just imagine what it will be like for the next launch when we have people riding in Starliner and this Atlas V being a human-rated rocket. It's pretty awesome.
Yeah, we heard the guys earlier saying they were jealous about Rosie.
Absolutely.
Well, just a few months ago, we were talking about how much confidence you have in the Atlas V rocket. And what made you say that?
Yeah, you know, we've been here a couple times watching launches, of course. Not
another interesting bit of about the Starliner is actually what vehicle it's going to be launching on. So basically, because the Starliner is, of course, launching on the Atlas V, the Atlas V is not actually going to be around for much longer because ULA has plans to start their next generation of rocketry, which is essentially going to be an upgrade to the Atlas V vehicle. And the questions are, well, if Atlas V is no longer being built, then how are we going to launch Starliner? So the question is, of course, are they going to human rate this next vehicle? And right now, that's not the case. So in the event that they don't actually human rate this launch vehicle, they actually won't have a way to get Starliner into orbit. But I think that this will be just a temporary problem. I think in the end they will, of course, human rate their next vehicle. But yeah, we'll see how that goes too. Yeah, let's listen to what's going on. Right now they have astronauts actually in the control room while they do this launch. They don't have astronauts on the ship, of course. They do have a mannequin though that is going to be taking all the sensor data of what it would be like to be an astronaut on the rocket. So it'll be recording like the accelerations to make sure that it's survivable. They're also going to be testing a spacesuit that Boeing has developed, which is going to be used inside of the Starliner vehicle. So hopefully they get some good data on the performance of that. But they also have some they have ways of kind of like displaying what is on Starliner's like view screens and instrument boards, and kind of having that also on ground so that astronauts are seeing what that looks like. And that's kind of the value of having them in the room while this is happening, is that you get kind of some real feedback about how the vehicle is responding and how an astronaut would be responding in that situation. So, yeah. But here we're talking to one of those astronauts that's in the room, so we can kind of continue listening on.
Not everything is going to go 100% correct, right? We learn stuff every time we take something to space, and so we're going to take those lessons learned from this mission and apply it to the next launch, which is the crewed flight test. But even beside for that, we have testing that we're ready to go do. We have the crew validation test, which is coming up this summer, where the three of us will be in the spacecraft, in the suits, in the seats, checking out the environmental control system, checking out the ergonomics, making sure we fit, we're ready to go. We also be working with the software folks, so looking at all the displays, making sure that all the displays tell us the right information and we understand it correctly, and we can work with mission control with that. So there's a lot, and then of course there's training with the control team. The control team, we've had some training with them, but leading up to this, they've been working on an uncrewed version, and now us little pains in the neck are going to be sitting in there talking back to them. So we're going to work through all that choreography of how we're going to work together in the spacecraft.
Well, Sonny, your time is valuable. I really appreciate you joining us here. I know you need to get back down to the console and follow along. So thank you for being here. And we are going to continue to follow along the loops here at the ASOC and wait for that orbital insertion burn, which is basically when Starliner will be up in orbit, hanging out until we're ready to start the rendezvous process and docking tomorrow. So for now, that's it for me and Sonny, and as well as Dylan Rice here in Florida. And we'll get you back over to Brandy and Josh in Houston.
Lauren, and great to hear from Sonny. We're now just about 2 minutes away from the orbital insertion burn. That again is going to be a 45-second burn. It's going to raise the perigee or the low point of Starliner's orbit out of the Earth's atmosphere and get it into a stable orbit. And after that, we'll begin checking out the critical control systems before tomorrow's docking.
This is actually a really cool graph that is showing you I believe the altitude of the vehicle.
Minute and a half until the orbital insertion burn. Starliner is in the burn attitude. You might have seen earlier the nose of Starliner might have been pointed down towards the Earth, but that's actually the attitude that it needs to be, because as it orbits around the Earth, it will no longer be pointing at Earth. It will be pointing at that specific point in space that the orbital insertion burn will send us to. And once again, there'll be a lot of thruster activity. We want those 4 aft-facing OMAC engines, that's about 1,200 pounds of thrust each, to be pushing in exactly the right direction.
OMAC standing for Orbital Maneuvering and Attitude Control. They're going to fire for 45 seconds for this burn, changing Starliner's velocity by 85 meters per second, or 190 miles per hour.
So they're not actually using the
30
big...
seconds to go now until that burn ignites.
They don't actually use the big rockets to do this maneuver. They're just using the little ones that are used for the maneuvering. And that's because they need precision. So they are able to be much more precise with how they insert into the orbit. And do fine maneuvering type of operations.
Insertion burn starting in 5, 4, 3, 2, 1. Again, this burn is going to last for 45 seconds. Teams here on the ground reporting 4 good orbital maneuvering and attitude control thrusters.
And you can see that all the thrusters are kind of firing all in different directions. Of course, they have the main ones on the bottom. And the reason why you have that is because the vehicle is stabilizing as it does this.
Now, the colors you're seeing on those jets, or you were seeing on those jets, they indicate which integrated propulsion controller those jets are mapped to. We have 3 IPCs, integrated propulsion controllers. OI cutoff in 5, 4, 3, 2, 1.
Well, it gets a little bit chaotic there at the end.
And we have OI cutoff. And And we have confirmation from Flight Director Mike Lammers. We have a good orbital insertion burn. Starliner is in a stable circular orbit on its way to the International Space Station.
All right, so it's officially better than
Now,
last time.
This was a big hurdle to get through early on. We have a few demos to go on our way to the ISS. And then after that, hopefully a very good docking. But so far today, good launch, great performance from ULA. Atlas even gave us a little bit more of a push than we needed, but Centaur was able to adjust accordingly, place Starliner exactly where we needed it. And we have confirmation of a good OI burn. Once again, Starliner is in orbit, heading to the ISS.
It's a major milestone to get behind us, but it is really just the beginning. We've got a number of demonstrations now that Starliner will have to go through ahead of its International Space Station arrival. Those are going to start pretty much right away with a checkout of the VESTA systems. VESTA stands for Vision-Based Electro-Optical.
You can see there that the Starliner is chasing the International Space Station, so it's a little bit behind. Basically, it's in a lower orbit than the International Space Station, and each orbit it goes through will get it a little bit closer, a little bit closer, a little bit closer, until, of course, in a couple days, it'll match up perfectly. So yeah, it looks like we're having a positive mission up to this point. Of course, the mission will be ongoing, and you can follow either...
Just a couple more things they're working through on their orbital insertion checklist. We have confirmation good radiator activation. So those radiators are now in control and controlling the thermal environment inside the cabin.
So basically you can follow up with any of the testing that they're going to be doing over the next couple of days, and then finally the rendezvous with the space station on either Boeing or ULA's social media channels. I'm pretty sure they post pretty regular Twitter updates, so you can definitely look up what's going on there. Yeah, so I'm definitely excited to see this mission pan out over the next couple of days, and we'll definitely be following it. It's good to see that Starliner will be a nice competition for Dragon 2, and that there can be multiple options for getting into orbit and to the International Space Station as a human. Maybe not for a good price yet. 90 million is pretty steep. I don't think there's many of us that could afford that. But luckily NASA has deep pockets, and they are at least able to support at this point. A little bit about myself and why we are doing this stream. Of course, I'm part of a rocket group from Astra called Astra Bremen, and we are trying to build a rocket which goes to space as well. We're just a student group, so we are not quite having the same funding as ULA and NASA, but we are hoping to be able to build a rocket that goes to the Kármán line, which is the official boundary for space, within the next 2 years. But to do that, of course, we need lots of support. So one way that you could support us is to check out our merchandise shop. So you see that I'm wearing a Astra hoodie. I'm often wearing these Astra hoodies in the streams and in the videos we do. So if you're interested in maybe getting something Astra related, we have a merchandise shop that you can check out. Here it is. And you can see here, yeah, we have different things. Some of the hoodies are there if you're interested in that kind of stuff that I'm wearing. We also have shirts and other bags and hats and stuff. So yeah, you can kind of check that out and see if you're interested. Of course, you can always also donate to the program as well. Every single donation is really, really valuable for us, of course, because we don't have a huge budget. We're just students. And yeah, every little bit helps us get closer to the Kármán line. So with that, we'll leave it there. Starliner officially is in orbit and ready to perform its next tests. So we're looking forward to what the coming days are for that. And remember to keep expanding your horizons.